Hello class, and welcome to today's algebra lesson, which is about special products. By the end of today's lesson, you will be able to identify special case binomial multiplications and use shortcuts to solve. So the first shortcut we have is called the square of a sum. So basically what it's saying is you're going to have the same binomial twice. So for example, if I had x plus 4 times x plus 4. So it's taking the same binomial and multiplying it twice. The shortcut for this is to square the first number. So in this case, I would be doing x squared. So taking the first value of each term and squaring it. Then I'm taking 2 times a times b, which means you're going to take the product of the two values, so x times 4, which is 4x, and then you're going to make that twice as big, which is 8x. This would happen because you will have the same value multiplied twice. And then you square the last value, so in this case 4 times 4 is 16. So for example here, if I have 8c plus 3d, all of that squared, I can take the first value and square it. So I'm taking 8c, and I'm going to square that, which is going to give me 64c squared. Then to get the middle value, I'm going to take 2 times the first amount times the second amount, because that's going to come from these two boxes that match. So I've got 2 times 8, which is 16, times 3 is 48, and then I have c and d, so it's going to be 48cd. And then I'm going to take the last piece, which is 3d, and square that as well, which is going to give me 9d squared. So again, this is a shortcut for if you are multiplying the same two binomials twice. If you prefer to continue for the sake of consistency, just using the box or the FOIL method and setting it up as 8c and 3d, and then 8c and 3d again, which is going to give you 64c squared, 24cd, again 24cd, and 9d squared. It's going to give you the same answer if you use this box method. So the things that you have been doing will still work. This is just a shortcut for you if you can identify that it's the sum of a square, so the same thing being multiplied twice. You don't actually have to write out the box. You can square the front, multiply and double the middles, and then square the back. Go ahead and try this one on your own. So using that sum of squared, we've got x squared, which gives you x squared. Then we take 2 times x times 3, which is going to give you the 6x. And then we take 3 squared, which is going to give you 9. The next rule is the exact same thing, but now instead of the square of a sum, it's the square of a difference. So it's going to be the same two things being multiplied, but now instead of addition between them, there's a subtraction between them. Once again, the first step is to square the first part, so in this case, x squared. Then you're once again going to multiply the middles and double them, so we have that same box that's going to repeat itself. So x times negative 4 is negative 4x, doubled is negative 8x, and then squaring the last part, negative 4 squared, gives you a positive 16. So if we go through and do this problem, we're going to take our first term and square it. So we've got x squared, which is just going to give us x squared. Then we're going to take 2 times the front times the back, which is negative 10. So we've got 2x times negative 10, which is negative 20x, so minus 20x. And then we take the back term squared, so negative 10 times negative 10, which is positive 100. Once again, if you prefer to just be consistent and just continue to use that box method for multiplying your binomials, you can set it up with x and negative 10 on both values, and we get x squared, negative 10x, negative 10x, and positive 100, again getting you back to that same answer. Go ahead and try this one on your own. So we start by squaring that front piece. 6p squaring that gives you 36p squared. Then we take 2 times the front piece of 6p times the back piece of -1, giving you -12p. And then we take the back piece and square it, which gives you a +1. The last piece we have for our special cases is the product of a sum and a difference. So we have the two values that are going to match, but their signs are different. So for example, if I have x plus 4 and x minus 4. In this case, you're going to multiply the first parts first. So in this case, it would be x times x. And then you're going to multiply the second parts. Oopsies, that should be a 4, not a b. 4 times -4, which gives you -16. Notice, this goes down to a binomial answer instead of a trinomial answer. The reason being, these two pieces will always cancel each other out. One will be positive and one will be negative. Anytime we do that multiplication, so in this case, it'd be -4x and +4x, those cancel out. So we don't include 0x in the middle. It filters down to just a binomial. So if we go through with this example, we're going to take and we're going to multiply the first two pieces. So 3n times 3n, which is going to give me 9n squared. Then I jump to the back, which is 2 times -2, which is going to give me an answer of -4. Once again, if you prefer the consistency of just staying with the box method, we can plug in our values, 3n and a +2, 3n and a -2, and I would get 9n squared, 6n, -6n, and -4. Again, those two boxes for multiplying the outside and the inside, so those two middle pieces, those would cancel each other out, and we would still end up with 9n squared minus 4. Go ahead and try this one on your own. So we multiply our first pieces of 4c times 4c, which gives you 16c squared. And then we multiply our second pieces of 7d times -7d, which gives you -49d squared. So we can also apply these rules of special products to help us do larger values being squared. So to help us find these bigger numbers without a calculator. Remember, mental math just means without a calculator. It does not mean that you cannot or should not be writing things down. So when we break this down, we want to break 94 into pieces that are much easier for us to square. So I'm going to break it down into 90 and 4. The reason I use 90 and 4 is because then I have a 0, and 0 squared is going to be really easy for us. So I can follow my sum of square rule because we're doing addition, and I'm going to start by doing the first term, so 90 to the second power. We can take 9 to the second power, which is 81, and then because it's 0 to the second power, we're going to double that. It's 90 times 90, so we have those two zeros that are going to be tacked onto our final answer. Then I'm going to take 2 times 90 times 4. Personally, I like to multiply the two smaller numbers first, so 2 times 4 is 8, and then we have 8 times 9, which is 72, and adding on our 1 0 is 720. And then I do the back part, which is 4 squared, which is 16. Because it is the square of a sum, we are adding these all together. If it's easier for you to add by arranging it as a traditional method of addition, so putting them vertically instead of this horizontal, we've got 0 plus 0 plus 6 is 6. We've got 0 plus 1 plus 2 is 3. We've got 1 plus 7, which is 8, and then 8 plus nothing, which is 8. So 94 squared is going to give you 8,836. Once again, if you've been consistently using that box method, you can break it down in the same format. So we still split it up into 90 and 4, but you just write out your multiplications a little bit differently. So we got 90 and 4, 90 and 4. We still have 9 times 9, which is 81, and those two zeros. Then we have 90 times 4, which is 360, 90 times 4, which is 360, and 4 times 4, which is 16. Again, you can set it up with our addition then, 8,100, 360, 360, and 16. And when we add all those up, I get 0 plus 0 plus 0 is 6. 0 plus 6 plus 6 is 12, plus 1 is 13. So we write down the 3, carry the 1. 1 plus 1 is 2, plus 3 is 5, plus 3 is 8. And then 8 plus nothing is still just 8. So we get to that same method, whether we use the shortcut rule or whether we use the box. Go ahead and try this one on your own. So we can split it up, or we can set it up in the box. Either way, you end up with 1,369. We also can use this mental math property to multiply bigger numbers as long as they are the same distance away from a given value. So what do I mean by that? If I'm doing 198 times 202, the number directly in between those is 200. So the first number I can get by doing 200 minus 2. If I do 200 minus 2, I get 198. Then I'm multiplying that by 200 plus 2, which is going to give us now that final method where we have one positive and one negative case. So if we are doing that, we then would go through and multiply our two front numbers. So 200 times 200, which gives you 2 times 2 is 4, with 4 zeros after it. And then we multiply our back numbers, which is negative 2 times positive 2, giving us a negative 4. Then all you have to do is subtract your answers. So we got 40,000 minus 4, which is going to give me 39,996. Once again, if you prefer the box method, you can set it up the same way, and we would get the 200 and the negative 2 on one side, the 200 and the positive 2 on the other side. Once again, 200 times 200 gives you 40,000. 200 times negative 2 is negative 400. 200 times positive 2 is positive 400. And then negative 2 times positive 2 is negative 4. Those 400s would cancel out since one is positive and one is negative, and we're left with 40,000 minus 4 again, which is still going to give you 39,996. Go ahead and try this one on your own. So both of these are one number away from 120. So either method, once you do your multiplication, you're going to end up with 14,399. If you have questions about this or anything else from the lesson, please feel free to reach out and let me know.